What are the eigenvalues and eigenvectors of the unit matrix? Well, let's see. Remember now that the matrix times the eigenvector is equal to the eigenvalue of the matrix times its eigenvector. So you replace the matrix with its value. Now, if you subtract lambda x from both sides, ax minus lambda x equals 0. Factorize, you have a minus lambda equals 0. But lambda is a single number now. So multiply it by I, unit matrix. Now, the determinant of a minus lambda I must be 0. Alright? Now, a is equal to this. So, here now, a 1001 minus lambda times I, which is 1001, is equal to, well, 0. But also, the determinant of that matrix is equal to 0. So what's this matrix going to be? Well, you have 1001 minus lambda 0, 0, lambda, when you multiply lambda. The determinant is 0. So what you have here is 1 minus lambda, 0 minus 0 is 0, 0 minus 0 is 0, 1 minus lambda. Determinant of that is equal to 0. So, determinant 1 minus lambda times 1 minus lambda minus 0 times 0 is equal to 0. Now, it means that 1 minus lambda squared is equal to 0. Square root both sides, 1 minus lambda is equal to, well, you can say plus or minus 0, but the plus or minus will make a difference here. So 1 minus lambda is equal to 0, so therefore lambda must be equal to 1. And that's the only eigenvalue we have. Now, here, remember, x times a minus lambda I is equal to 0. So let's write that. X is the vector. In our case, x, y times 1 minus lambda I. What was 1 minus lambda I? It was this. Because remember, we had a minus lambda I, it was that a minus lambda times I, and it simplifies down to 1 minus lambda 0, 0. 1 minus lambda. 1 minus lambda 0, 0, 1 minus lambda. So, x times a minus lambda I equals 0. So this gives us 0. Now, we have lambda being 1. So, this turns out to be 1 minus 1, which is 0. And this turns out to be 1 minus 1, which is 0, because lambda is 1. And of course, we cannot multiply a 2 by 1 by a 2 by 1 matrix by a 2 by 2, but we can multiply a 2 by 2 matrix by a 2 by 1. So, what is the eigenvalue? The eigenvector here, 0 times x plus 0 times y. 0x plus 0y is equal to 0. Now, here, it means that 0x is equal to 0y. Now, x and y, what is suggesting? That they can be anything, but they are equal. But it seems like x and y are 0. Now, if x and y are 0 and lambda is 1, let's test this out. A was 1, 0, 0, 1 times x, let's use x equal 1, y equal 1, is equal to lambda is 1, multiply it by the unit matrix times x. Let's use x is 1, 1 and see if it will work out. 1 by 1 is 1, 0 by 1 is 0, 1 plus 0, 0, 1, 0 plus 1, 1, 1 equals 1, 1, 1, 0, 1, 0, 0, 1, 0, 1 times 1, 1. 1 plus 0 is 1, 1 plus 0 plus 1 is 1. So here, it works when we put x and y being equal to each other and they are not 0, right? Now, here, we looked at the steps of finding the eigenvalue and the eigenvector for a 2 by 2 matrix. And I just wanted to check out what it would be for this matrix, the identity matrix. Alright, so I'll see you in the next video.